Let's practice solving one-step equations that have addition and subtraction as the operations. For questions 1 through 4, let's start off by seeing if we can find the solution to the given equations if we have a solution set. We're going to show detailed and logical work that supports our answer. So let's see, for number 1, we have x plus 12 equals 31, and we have 4 choices, negative 19, 9, 19, 29, and 43. So one of these is going to be the solution. So let's start off with looking at negative 19. Well, if we took negative 19 and plugged it in here, negative 19 plus 12, I guess ask yourself, is that going to be positive or negative? It's, I think, just going to be negative 7, so that's not going to work here, right? So let's go ahead and cross that one out. What about if we say x could be 9 here? Well, what's 9 plus 12? Well, 9 plus 12, I think that's 21, which is not 31, so that one's also not going to be the answer choice. Now what about 19? If we take 19 and plug it in here, let's see, 19 plus 12. Let's see, 19 plus 12, I think that is 31, so I think that is the solution here. So we're going to go ahead and say that we found our solution. It's going to be 19 here. So we can say that x is going to be equal to 19. Now to show that this does work here, we can take this 19 and go ahead and add that 12 to see if it does equal 31. You can go ahead and ask yourself, what is 19 plus 12? Because 19 plus 12, the expression is going to be equal to 31 on the left side, and the expression is 31 on the right side, then this must check out here. All right, for number 2, we have y minus 14 equals 27. So we have 1, 2, 3, 4, 5 different answer choices. One of these will be the solution. We got to find which one it is. So for negative 41, if we go ahead and substitute that in for y, negative 41 minus 14, well, that's the same thing as negative 41 plus negative 14, which gets even more negative. So that can't be our answer. All right, what about for negative 13? If we go ahead and try that one, well, negative 13 minus 14, for the same reason as the last answer choice, it won't work. This is the same thing as negative 13 plus negative 14, which is negative 27, which is not what we're looking for either. If we try this 13, if we go ahead and plug it in here, 13 minus 14, well, we're taking away more than what we have, so that would be a negative number, so that can't be it either. What about 41? Well, if we take 41 and plug it in here, let's see, actually, maybe we can write it this way, 41 minus 14, that would be, you got to borrow here, that would be a 3, that would be 11, that would be 7, oh, that is 27, so this would be our answer choice here, it would be 41. So here, we can say that y would be equal to 41. All right, so we can go ahead and show this by saying, well, if we take this 41 and we take away 14, that should equal 27, right? Well, again, just double check that 41 minus 14, that is going to be 27. So if you're sure that is true, 27 does equal 27, the left expression equals the right expression, then this is correct. That means y does equal 41 here. For number 3, we have the equation m plus 7.9 is equal to 13.4. Looks like we have 1, 2, 3, and 4 different answer choices to choose from here. So let's see, if we take this negative 21.3, let's go ahead and add 7.9 onto that. So negative 21.3 plus 7.9. I guess ask yourself, would this be positive or negative? I think this would still be negative, right? So this can't be the answer choice. We need 13.4, so that can't be right. If you take this negative 5.5 and then plug that in here, negative 5.5 plus 7.9, let's see, well, we're in the negatives, we go and add positives. We would go ahead and subtract these absolute values and you would get, I think, like 2.4 or something, so it's definitely not 13.4, so this does not work either. What if we try positive 5.5? Well, positive 5.5, let's see, 5.5, this one actually could work, right? 5.5 plus 7.9. That would be 14, carry the 1. I think that would be 13.4. So I think this would be our answer choice. It would be 5.5 here. All right, so here we can say that to solve this equation, the only number that m could be here is going to be 5.5. And so to show this, we should make sure that both sides of this equation are the same value. So 5.5 plus 7.9. The left side of the expression, does that equal the right side of 13.4? So both expressions have to be the same. 5 plus 7 is 12. 0.5 plus 0.9 is 1.4. 12 plus 1.4 is going to be 13.4. So again, just double checking and making sure we are 100% correct here. This does check out, and so m does equal 5.5. For number 4, we have this equation n minus 4.8 is equal to 5.9. We have 1, 2, 3, 4 different choices to choose from here. Let's check out this negative 10.7 first. If we go ahead and plug that in, negative 10.7 minus 4.8. Well, let's see, that's a negative minus a positive. You can rewrite this as negative 10.7 plus negative 4.8, but that would just be more negative, and we're trying to get to positive 5.9, so that can't be right. So let's get rid of this one here. Let's take this negative 1.1. If we plug that in here, well, let's see, for the same reason, a negative minus a positive is just going to be more negative. So this would be negative 1.1 plus negative 4.8. That would also be a negative answer. So this can't be right either. What if we try this positive 1.1? If we plug that in here, 1.1 minus 4.8, well, we're taking away more than what we have, so that would also be a negative answer. So by process of elimination here, I think our answer has to be 10.7 here. So we can go ahead and say that n would equal 10.7. Now let's go ahead and just check this real quick. If we take this 10.7, we think that's the value for n. Go ahead and take away 4.8. I guess the question is does that actually equal 5.9? And you want to definitely make sure and double check here. I'm going to go ahead and write it just like this though, 10.7 minus the 4.8. We would borrow here from the 1, make it a 0. This would become a 10, but then we would borrow again, make it 9. This would be 17. So 17 minus 8 would be 9, and then 9 minus 4 would be 5. So we do have 5.9. So this does make sense, even though we just kind of knew from the other ones not working, but we just verified here that since the two expressions equal each other, then n does equal this 10.9 that we found out. All right, let's try questions 5 through 8. Here we're going to be going ahead and solving these equations using an inverse operation. Then we'll use the identity property of addition, and then we have to go ahead and check our solution to make sure we are correct. All right, so number 5, we have x plus 1.58 is equal to 5.21. So let's see, if we're going to use an inverse operation, here we can see our problem has addition. So the inverse operation is going to be subtraction. So we're going to take this x plus 1.58 is equal to 5.21. The inverse operation is going to be subtraction. So let's go ahead and take away 1.58 and take away 1.58. So you have to do that on both sides of the equation here. All right, when we do that, we can see here that a positive 1.58 and a negative 1.58 are going to become 0, because when you add opposites, you always get 0. So you're going to do x plus, and then that's going to turn into a 0. And on the right side, we're going to have to figure out what this 5.21 minus 1.58 is going to be here, right? So let's go ahead and do 5.21 minus the 1.58 on the side. This is just going to be our little computational work here. So let's see, we're going to borrow from this. Will be a 4. This will become a 12, but then we're going to borrow again, so it's 11. And this will become 11. So 11 minus 8 is 3. 11 minus 5 is 6. 4 minus 1 is going to be 3. So we're looking at 3.63. Okay, then let's go ahead and use the identity property of addition, which means you can just drop that 0 because x plus 0 is just x. So x would be equal to 3.63. All right, so we think this would be our solution, but let's go ahead and check it now by taking our answer here and substituting it in for x to see if this is true. So let's go ahead and check it now. Let's take this 3.63 and let's add the 1.58 here and see if this does check out and equal 5.21. So 3 plus 8 is going to be 11, carry the 1. 1 plus 6 is 7, plus 5 is going to be 12, carry the 1. 1 plus 3 plus 1 is going to be 5, so this does equal 5.21. So this does check out here. Okay, let's check out number 6. For number 6, we have some fractions here. So let's go ahead and just write down the equation first. We have y plus 1.6. That's equal to 3 over 10. Okay, so what's the inverse operation here? Well, we have addition in the problem, so the inverse operation is going to be subtraction. So let's go ahead and take away 1/6 from both sides here. And the goal here is to get 0 on the left side. If we do that, we're going to get y is going to be adding what number here? Well, positive 1/6 minus 1/6 is going to be 0, so we're going to be adding 0. And on the right side, what are we going to have here? Well, we have to figure out what this 3/10 minus 1/6 is going to be. Now, when do 10 and 6 meet for the first time? Well, I think if we go through our least common multiples, that's going to be 30. So we go ahead and multiply this first fraction by 3 and 3. That's going to be 9 over 30. And then we're going to go ahead and take away what fraction here? Well, 1/6 to get to 30, we could do times 5 times 5. So I think that's going to be 5 over 30. So it's going to be minus 5 over 30. So now that we have common denominators, 9 over 30 minus 5 over 30, that's just going to be 4 over 30. And 4 over 30, let's see, I'm going to write equals 4 over 30. But you can simplify that to just 2 over 15 here, right? If you go ahead and divide by the GCF, so 2 over 15. Then using the identity property, we can drop the 0 and just say y is equal to 2 over 15. This would be our solution. But let's go ahead and check it. Let's take this 2/15 and let's substitute it back in for y here. Let's add 1/6 to verify it equals 3/10 here. All right. So let's go ahead and take this 2 over 15. Let's go ahead and add the 1 over 6, right? Now, when do 15 and 6 meet for the first time? That's going to be 30, I believe. Let's do times 2 times 2. Let's do times 5 times 5. So let's see here. If we go ahead and do that, that's going to end up being 4 over 30 plus, this one's times 5 times 5, so it's going to be 5 over 30. So that's going to equal 9 over 30. And what's a common factor between 9 and 30? I think we can divide top and bottom both by 3, right? So if you do that, 9 divided by 3 is going to be 3. And then 30 divided by 3 is going to be 10. So you can see this 3/10 matches the 3/10 we had earlier. So this does check out, and y does equal 2/15. All right, let's check out number 7. For number 7, we have x minus 4 and 85 hundredths. And that's going to be equal to 7 and 29 hundredths. So let's go ahead and see what we're going to do here. It looks like the operation here this time is subtraction. So what's the inverse operation? The inverse is going to be addition. So let's go ahead and add 4.85 to the left side. And if we do that on the left, we should do it to the right. Let's add 4.85 to the right side as well. All right, on the left side, what's going to happen here? Well, this negative 4.58 and positive 4.58, those are opposites. So when you add opposites, you always get 0. So we're going to get x plus 0 is equal to, and what's going to happen over on the right side? Well, on the right side, we're going to have to go ahead and add these two numbers together here and see what that's going to be. So let's take this 7.29. Let's go ahead and add 4.85 to find out this answer here. Okay, so let's see, 9 plus 5 is going to be 14, carry the 1. This is going to be 11, carry the 1. And I believe this is going to be 12. So I think 7.29 plus 4.85 is going to be 12.14. And then we can use the identity property of addition and drop that 0 and just say x is equal to, we think, 12.14. But we can check this in just a sec. All right, so we think x is 12.14. So let's go ahead and see if that's true. Let's substitute it in here. Let's see. Let's see if 12.14 minus the 4.85. Let's verify whether this is true or not, if it equals the 7.29 here. So let's see. 4 minus 5, can't do. Let's borrow. I think we're going to borrow all the way from this 1, so that'll become 0. This will become 12. We're going to borrow to make it 11. This will become 11. We're going to borrow, make it 10. And this one becomes 14. We're not going to borrow again here. 14 minus 5 is going to be 9. We like the 9. 10 minus 8 is going to be 2. We like the 2. Then 11 minus 4 is going to be 7. And we like that 7. So notice this 7.29 matches this one perfectly. So we know that our answer does indeed equal, x does equal this 12.14. Let's try one more of these types of problems. We have this equation y minus 3/8, so the operation is subtraction. Hopefully you're thinking of the inverse operation is addition already. All right, so what's the inverse of subtraction? Well, we just said it, it's addition. Let's go ahead and add 3/8 to the left side and add 3/8 to the right side. All right, so why are we going to do that? Well, if we take a look here, these are opposites. Those opposites always make 0, so we're going to get y plus 0 is equal to, and then what's on the right side of the equation here? Well, on the right side we have 5, 6 plus 3/8. Let's go ahead and figure out that. Let's see, when do 6 and 8 meet for the first time? Well, I think it's going to be 24. If we do times 4 times 4 and times 3 times 3, I think we're going to get common denominators here. So I think this is going to be equal to 20 over 24 plus, and this is times 3 times 3, so I think 9 over 24. So 20 plus 9 is going to be 29. I think this is going to be 29 over 24. So this isn't a word problem or anything, so we're going to leave it alone as an improper. Using the identity property of addition, we can drop the 0 and just say y is equal to 29 over 24. All right, so we think that's going to be our answer for the value of y. Let's go ahead and now substitute this in for y and see if this checks out. So let's go ahead and take this 29 over 24. Let's go ahead and subtract this 3 over 8. Now 3 over 8, if we want to make it 24 on the denominator, let's go ahead and multiply it times 3 times 3. If we do that, it's going to be 9 over 24. And let's see if this does equal to 5, 6. Well, 29 minus 9 is going to be 20, so we're looking at 20 over 24. Then if we divide top and bottom by, I think, 4, we're going to get 5 over 6. And so since this 5 over 6 matches the 5 over 6 over here, then we should feel really good about our answer being 29 24ths. Now, if you wanted to go ahead and also write our answer as 1 and 5 24ths, go ahead. But for these problems where it's not application based, I think improper fractions are also okay. All right, let's go ahead and check out a couple application problems now. So for questions 9 through 10, we're going to go ahead and apply our understanding. We have to go ahead and set up an equation that best represents the scenario that we're given. Then we're going to go ahead and show detailed and logical work, then write a conclusive statement since it's a word problem or application problem. So after being given $55 for the Lunar New Year, Hannah now has $112 saved up. Determine how much money Hannah had saved up before the Lunar New Year. Okay, so how much money did she have before? Well, we don't really know here. So we're going to go ahead and maybe use the variable m for some unknown amount of money. But she's being given more money here, right? She's being given $55. So we're either going to add or subtract here. Well, we're adding since she's being given more money. How much was she given? Well, the changing amount, or how much she was increasing or decreasing by. In this case, she was given $55, so she added $55 to her savings, or how much she has. And this is going to result in what amount of money? Well, now we know she has $112 saved up. So we're going to say that's going to be what we're ending up with here, $112. So this is how we set up our equation. We're going to say m plus 55 is equal to 112. Okay, so we can go ahead and say, let's use an inverse operation. So to solve this, let's go ahead and take away 55. So what if we went back in time and she wasn't given the $55? Then we can figure out what she had before. All right, so 55 and negative 55 are going to cancel each other out. So we're going to say m plus nothing. What if she had no money given for Lunar New Year is equal to, and what's 112 minus 55? So this is what you would do for maybe some scratch work on the side. 112 minus the 55. Let's see, we're going to have to borrow here. So this would become a 0. This would become 11, but we're going to have to borrow to make it 10. This would become 12. 12 minus the 5 is going to be 7. 10 minus the 5 is going to be 5. And then 0 is just 0. So I think this is going to be 57. All right. Using the identity property of addition, we can drop that 0 and just say m is equal to 57. Now, what did m represent again? M represented the starting amount, or how much money Hannah had before the Lunar New Year. So we can conclude that Hannah had $57 before the Lunar New Year. All right, let's go ahead and try one more problem here. So in number 10, it says after using 2 3/4 cups of flour to bake some cookies, Stella now has 5.5 cups of flour left. Determine how much flour Stella had before baking some of these cookies. So let's see, the starting amount, we don't know right now because we are trying to figure out what she had before. I'm going to use F for the amount of flour. She's going to be using 2 3/4 cups of flour. So that means she has less flour. So if she's using it up, you're subtracting from how much she has. So the changing amount, how much is she getting rid of or using for the cookies for the recipe? She's using 2 3/4, right? That's being used up to make the cookies. And this is going to result in what amount? So it's going to result in how much she has left. So the resulting amount is how much she has left. And that's going to be 5 1/2 cups left. Okay, so our equation here is going to be the amount of flour she had to begin with minus what she used up, and that's going to be equal to what she has left. This is going to be the 5 1/2. So to go back in time here and to unuse the flour, or put it back rather, let's go ahead and add 2 3/4 to both sides. This is the inverse operation here. If we go ahead and take this 2 3/4 and add it to the negative 2 3/4, that's going to become 0, right? That's going to be F plus 0. It's like saying, what if Stella didn't use any flour? And on the right side, we can go ahead and solve this. We have to figure out what 5.5 plus 2 3/4 is. We need common denominators. This one's not too bad though. Let's see, for the half and the fourths, let's just make them both fourths. So we can do times 2 times 2. So if we do that, it's going to be 5 2/4 plus this 2 3/4, right? Now they have common denominators. That's going to be, you can add the whole numbers to make it 7. And then if you add the fractions, that's going to be 5/4, so 7 5/4. Now that's a little awkward just because we have an improper fraction and a mixed number here. So we can regroup and say this is going to be 7 plus 1 1/4. And that's just going to be equal to 8 1/4 here. So the other side here, or what we had before, or what if Stella didn't use any flour, should be 8 1/4 to begin with. So using the identity property of addition, we can drop the 0 and just say the amount of flour Stella originally had was 8 1/4 cups. So in conclusion, we can go ahead and say that Stella had 8 1/4 cups of flour before baking cookies. All right, so there you have 10 different practice problems on solving one-step equations that had addition or subtraction as the operation. If you found the video helpful, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep with the great work that you're already doing.